You know, sometimes the universe throws us a curveball. Here, we see a galaxy so far away and so long ago that its shape just doesn't fit with what we thought we knew. It's elongated, almost like a pool noodle or maybe a surfboard, and honestly, it's kind of mesmerizing. For generations, our cosmic textbooks painted a clear picture of the early universe, a chaotic, turbulent place where the very first galaxies were expected to be small, irregular blobs slowly coalescing under the nascent tug of gravity. The grand spirals and elegant ellipticals we admire today were thought to be products of billions of years of mergers and evolution. This was the accepted narrative, a cornerstone of our cosmological understanding. Then came the James Webb Space Telescope, or JWST. With its unparalleled ability to peer back in time, JWST is not just observing the early universe, it's actually rewriting its history. Among its most baffling discoveries are galaxies that defy our expectations, surprisingly common elongated pool noodle or surfboard-shaped galaxies existing just a few 100 million years after the Big Bang. These aren't the messy blobs we predicted. They are strangely structured, defying the conventional timeline for galactic morphology. What cosmic forces are at play folding the universe's first galaxies into such unexpected forms? How could such distinct shapes emerge so rapidly in the cosmic dawn? At the 11-dimensional model of the universe, we propose a revolutionary answer. These oddly shaped galaxies are not anomalies, they are direct evidence of a deeper dimensional choreography. Our model reveals how the intricate interplay of 11 dimensions acts as a cosmic origami master, shaping the very fabric of early galactic creation. The James Webb Space Telescope's mission is to observe the universe's infancy, capturing light from objects that formed just a few 100 million years after the Big Bang. Its infrared vision allows it to penetrate the cosmic dust and gas that obscured earlier telescopes, revealing a universe in its raw, formative stages. What it's found has left cosmologists scratching their heads. Instead of a universe dominated by small, disorganized or spherical clumps of stars and gas in its youth, JWST is consistently spotting a significant proportion of galaxies that are distinctly elongated and flattened. These aren't the thin, elegant disks of mature spiral galaxies like our Milky Way, which take billions of years to form through mergers and rotational flattening. These are primordial structures, appearing remarkably early, with shapes described as resembling pool noodles or surfboards, long, thin, and often lacking the chaotic appearance of expected early irregulars. For example, studies using JWST data have found that a large percentage, sometimes cited as 50 to 80%, of galaxies observed between 600 million and 6 billion years after the Big Bang exhibit these flattened, elongated morphologies. This is a profound challenge to standard galaxy formation models, which predict that such ordered, flattened structures should only emerge much later in cosmic history, after extensive gravitational interactions, mergers, and rotational flattening over vast timescales. The sheer prevalence and early appearance of these flat galaxies suggests that something more fundamental than conventional gravitational dynamics is at play in the early universe. To unravel the mystery of JWST's unexpectedly shaped galaxies, we must turn to the 11-dimensional model of the universe. This framework posits that reality is not merely composed of matter and energy within a static space-time, but is actively orchestrated by a hierarchy of interconnected dimensions. At its most fundamental level, the universe is a ceaseless dance between two primary forces. The 10th dimension is the expansive, deterministic drive. It represents the outward push of the universe, the grand cosmic order, and the deterministic laws that govern classical physics. It provides the structured canvas for reality. The 11th dimension is the contractive quantum web. It embodies the universe's inward pull, its fundamental interconnectedness, and the probabilistic non-local nature of the quantum realm. It is the dimension of raw potentiality and universal connection. The continuous dynamic tension and interplay between these two dimensions generate the universal wave, the very fabric of reality itself. Everything in existence, from the smallest quantum fluctuation to the largest galaxy, is a unique manifestation, a distinct knot or dimensional resonance within this universal wave. This means that the gas clouds and dark matter halos that eventually form galaxies are not merely passive collections of particles, they are active, resonating portions of this underlying universal wave. The shapes they take are not just products of random gravitational collapse, but are fundamentally influenced by the underlying topology and dynamics of this higher dimensional wave. Here lies the 11-dimensional model's profound explanation for JWST's so-called pool, noodle and surfboard galaxies. The early universe was honestly a unique dimensional environment, really unlike anything we observe today. Immediately following the Big Bang, which, in our model, is a monumental dimensional unfolding, a grand eruption from a previous hypercompressed state, the universal wave was in this incredibly potent and rapidly evolving state. In this primordial era, the dynamic interplay of the 10th and 11th dimensions, along with the influence of other higher dimensions, created a very specific dimensional choreography that actually favored the formation of elongated and flattened structures. Imagine the universal wave, not as a smooth, uniform ocean, but as a turbulent yet patterned cosmic sea. Now, preferential resonance and standing waves, the intense high-energy conditions of the early universe, might have caused the 10th and 11th dimensions to form these specific types of standing wave patterns or dimensional eddies within the universal wave that were inherently elongated or flattened. These aren't just random fluctuations, they're stable, repeating resonant forms. Think of how certain frequencies create specific shapes in a Chladni plate experiment. The universe, at this fundamental dimensional level, was preferentially ringing out these elongated forms. Efficient matter collection. These pre-shaped dimensional forms acted as highly efficient cosmic templates. Primordial gas and dark matter, which are themselves dimensional knots within the universal wave, would have been rapidly and preferentially drawn into these elongated eddies. This allowed matter to aggregate into massive, flattened structures far more quickly and efficiently than standard gravitational collapse alone would permit in a purely three-dimensional space. It's like the riffles and water of our cosmic sluicebox analogy were arranged at this early stage to specifically filter and concentrate matter into these noodle or surfboard shapes. Once matter accumulated within these dimensionally favored templates, gravity, which in our model is an emergent property of the 11th dimension's contractive pull, then acted to localize and solidify these pre-shaped forms, giving rise to the surprisingly coherent and massive elongated galaxies observed by the James Webb Space Telescope. This explains why these galaxies appear so early and so commonly. Their shapes are not the result of billions of years of slow, chaotic mergers, but rather the direct, rapid manifestation of the early universe's unique dimensional orchestration. The James Webb Space Telescope has presented cosmology with a profound puzzle galaxies in the early universe that defy our expectations, appearing with strange, elongated shapes that shouldn't exist so soon. This challenge to our standard models is not a flaw in the universe, it's an invitation to expand our understanding. The 11-dimensional model provides the missing pieces. It reveals a cosmos where creation is not merely a random aggregation of matter, but a beautifully orchestrated process guided by a deeper, dimensional blueprint. The unexpected shapes of these early galaxies are powerful testaments to the active influence of the 10th and 11th dimensions, shaping reality from its very inception. By embracing this model, we gain a new cosmic map, One where the universe's most surprising discoveries find a coherent and elegant explanation. It's a universe that is far more dynamic, more interconnected, and more fundamentally designed than we ever imagined. The cosmic architects are not hidden. They are the very dimensions shaping reality. Uncover the universe's true architects. Explore the 11-dimensional model. And hey, don't forget to subscribe to our channel.